When you're working with square roots, just like when you're working with fractions or anything else, you need to be able to simplify. Now, simplifying square roots, what we're focusing on mainly is just perfect squares. Now, when we talk about perfect squares, we're talking about the numbers like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. Okay, so when we're talking about these numbers, we're saying, you know, I can square root that. So if you don't know already, the square root symbol is like this. And what it's saying is, if you were to square root that number, you're asking yourself what number times itself gives you that number. So square root of 16 is 4, because 4 times 4 is 16. So when we get to a number like one of these down here, where there is no perfect square, 20 is not a perfect square, what we're going to do is we're going to break it up so that is a collection of perfect square and not perfect square. So I often tell people to have a list of perfect squares on their paper, because you want to find the biggest number in that perfect square that goes into it. In this case, it'd be 4. So 4 times 5 gives me 20. So now I'm going to rewrite it as a square root of 4 times 5. Now I'm looking at those, and I'm going to separate them into the square root of 4 and the square root of 5 separately. And then the square root of 4, well, 2 times 2 gives me 4, so square root of 4 is 2. And then I still have the square root of 5. And now 5 is not a perfect square. It's also prime. It doesn't have anything that goes into it, much less a perfect square. So because of that, this is simplified as far as it can be, and this would be my answer. Now, if we look at our second example here, the square root of 50, again, I'm looking through this list, and I want to find the biggest number that goes into 50. And the biggest number that I have here that goes into 50 is 25. So I'm going to rewrite that as 25 times 2, because that's how I get 50. Then I can split those up, square root of 25 and the square root of 5. Now the square root of 25 is 5, and then I don't know the square root of 5. It's going to be some decimal, and I don't want to get any decimals. Do not give me decimals as answers here. I want it to stay as the square root of 5. If there is no perfect square, you can take it out. So this is the answer to these. Now that's only the first rule, but that is the most complex rule. We have another rule. And that other rule is that you can't have any square roots in the denominator. Now, when you get to Algebra 2, we're going to be a little bit more difficult and complicated with this. But for now, you're going to be lucky enough that if you have a square root in the denominator, you should be able to just do the math. So square root of 9 is 3, and we've taken care of that square root in the denominator. Our third rule is that you cannot have any fractions inside a square root. So you'll see here that I have a fraction. So what I'm going to do is I'm going to split it up so I don't have any fractions inside the square root. I'm going to square root them separately. So square root of the top, square root of the bottom separately. Then what I'm going to do is I don't know the square root of 3. I can't do anything there. But I can take the square root of 16. The square root of 16 is 4. The other thing I want to make sure I'm looking at is if there is a perfect square in here, which there isn't in this case, but sometimes there might be a perfect square in there that you can then take out like we did in the first rule and then simplify. But otherwise, if there's a fraction inside the square root like we have here, split it up into 2 different ones and do what you can with your square root.